A system that provides rapid public transport is called a rapid transit system, or an RTS or short form. And a capacity is defined as the maximum amount that something can contain. So with this, let's find out the maximum amount of passengers that a rapid transit system or an RTS can contain. So welcome to this lecture, guys. And before starting, there are a few concepts that are necessary for us to understand. We are going to go into all of them one by one. Our very first one is the concept of time headway. Now, you see this spot here, A, that is highlighted. That is a frame. That is a point of reference. It can be anything. It can be a station. It can be a important crossing. It can be any reference that we pick. And let's say that this one bus, this first grey colored bus, it passes from this point at a certain time, say 12 o'clock in the afternoon. And after 10 minutes, this weird colored bus, okay, I honestly don't know what color this is, but anyway, this weird colored bus passes through the same point. The difference in time between these two buses passing this same reference point is your time headway. It is measured from the head of your bus, head of your next bus. Time headway, it has a very simple formula, is equal to 60 divided by frequency. Now, our frequency is vehicles per hour. So, when I say that, there are 6 vehicles per hour, what does it mean? It means that a vehicle is passing through my reference point every 10 minutes, right? Because see, let's just jump. Let's just do it here. My first vehicle, 10 minutes. Okay. Second vehicle, 20 minutes. And my third for 30, 40. We are getting into messy territory here, but you get it, right? So in 60 minutes, 1, 2, 3, 4, 5, and 6 buses are passing through a certain point. And that means my frequency is what? 6 vehicles per hour, and my time headway becomes 60 by 6, 10 minutes. So every 10 minutes, a bus passes through this point, and the frequency of that is 6 vehicles per hour. Now, you might have already seen this thing a little bit, but reliability, how reliable my system is. When I say that there is a bus coming here, or there is a metro train coming here every 10 minutes, it's not necessary. There are certain delays in the system. So that is what reliability is. It is a determination of how accurate or how on time your whole system is running. So let's say out of 100 vehicles, 90 vehicles are on time. You stand at a bus station and you count that out of 10 vehicles, 9 were on time and 1 was late. So the system is 90% reliable, right? 90% of the time, the buses are coming at their designated time, so it's fine. So we have 3 things clear actually: your time headway, your frequency, and also how reliable the system is. Now let's just go for vehicle capacity. Vehicle capacity is the maximum number of vehicles passing a point per hour per direction. Per direction is very important. And it has a very simple formula, 60 divided by h. Now, if you had paid attention over here, you know what that is. 60 by frequency is time headway. So, frequency is equal to 60 divided by time headway. So, CV, your maximum vehicle capacity, is equal to either 60 divided by h or frequency into R. R is your reliability. We are also going to solve example. We'll look into it in detail later. Now let's go to a fifth point, which is load factor. Let's just imagine that this is a bus and these are all the seats. So all the seats that are colored yellow, that means someone is occupying them. And all the seats that are blue, that means they are empty. So for our first case, we have a total of 20 seats here and all of them are packed, 100%. So our load factor is the total number of passengers divided by the total number of seats. Okay, in this case, my total number of passengers are 20 and my total number of seats are 20. So my load factor becomes 1. In this second case, let's just count it. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Only 10 seats are filled. The rest are all vacant. So my load factor here would be total passengers divided by total seats. So 10 divided by 20, 0.5. My load factor becomes 0.5. Now there is the third case in which you see these 1, 2, 3, 4 people are there. There are no seats here actually, but they're standing. So my total number of passengers become 24, but my total number of seats are 20 only. So the load factor becomes 24 by 20 equals 1.2. We're going to use it to calculate the maximum capacity of passengers that a system is carrying. And with that, let's go to this thing. Yep. Your passenger capacity or person per hour. A maximum number of passengers moving across a point in 1 hour per direction. Very simple. In one direction, how many number of people are moving across a point? That's it. And its formula is Cp, it is denoted as Cp is equal to Cv. What is your Cv? Cv is nothing but a vehicle capacity. The number of vehicles passing through a point. Okay, that is what vehicle capacity is. And passenger capacity is the number of passengers moving across a point. So, back to it. Cp is equal to Cv, your first thing, vehicle capacity into this number of coaches. Now, we have just been talking about BRTS. So, a bus usually has only one coach. So, if you're taking an example for a bus, your N is equal to 1. This is a single coach. Metro trains, there are 4 coaches. So, at that point, your N becomes 4. Now, we have cleared our Cv, which is a vehicle capacity. The number of coaches is clear. And the number of seats in a vehicle. Number of seats in a vehicle, I haven't written it here, but it is per coach. So, if there are 70 seats per coach, that means you would be doing Cv into 4 into 70. And the last thing you see here is A. A, if you remember, is a load factor. It doesn't matter if there are 20 seats, but if 24 people are traveling through that compartment, we have to take those 4 into consideration too, right? And with that, we have cleared all the basic points that you need to know to calculate a maximum capacity. Let's go to our sum here. The question is, zoom out a little bit and yeah. So, we are going to find the maximum passenger capacity per hour of BRTS and Metro for the frequency of 60 trips per hour. Let's just write all the data we have. First of all, we have frequency F is equal to, what is it? It is 60 trips per hour. We can also write it as 60 vehicles per hour. We have also been told to assume a few things. Permissible standing is equal to 10%. Now, what they mean by this is that it's okay if 10% people are standing, right? Basically, they're telling you that if there are 10 seats, then they are fine with 11 people traveling in that compartment. Okay, they are okay with one person standing. Now, what is this? This is your A. This is your load factor. So it becomes 1.1, right? 10%. So it's 1.1. Now, what do we have? We have your reliability is 100%. Okay. All the vehicles coming on time, so that is good. And they're told one coach with 50 seats for BRTS and 4 coaches, each of 75 capacity for metro. And what do we need to find? We need to find a maximum passenger capacity per hour. So, we have this formula for maximum passenger capacity. What is it? CP is equal to CV into N. N is our number of coaches, which is 1 for BRTS and 4 for metro. S is your seats, 50 for BRTS and 75 for metro. And A is your load factor. Load factor, as they've said, assume permissible standing is equal to 10%. So, load factor 1.1 is acceptable. Now, in this entire equation, we don't have one thing, and that is this CV. If you remember CV is equal to, what is it? 60 divided by H, right? Can also go up here. Okay. Vehicle capacity. CV is the maximum number of vehicles passing a point per hour per direction. What is it? 60 divided by H into R. Now, I had told you earlier that what is 60, that time headway or H is 60 divided by frequency. So, what is frequency? Frequency is equal to 60 divided by time headway. Simple cross multiplication. So, my CV becomes, instead of 60 divided by H, I can directly write frequency into R. So, CV, let's write here again. CV is also equal to F into R. Now, in this case, they have told me to take R as 100, even here 60 divided by H into R, but it was 100, so I just ignored it. So, F into R, what is my F? 60. R is 100%, so we take it as 1. And that means that CV is equal to 60 vehicles per hour. Okay, now we have all the things that we need. We have our CV, we have our N, we have our S, and we have our A. So for BRTS, let's go for it. CV is 60. My N is, what is my number of coaches here? It is 1. S, the number of seats, it's 50. And my A, my load factor is 10%. So 10% extra, 1.1. This entire thing is equal to, let's just quickly multiply it. It's 3300% per hour. Okay. So my BRTS is capable of carrying how many? 3,300 people per hour. Let's similarly find it out for your metro. The CV is going to say the same. N, my number of coaches are now 4. And my number of seats are now 75. My load factor, we'll keep it the same, 1.1 equal to, this is 19800 persons per hour. And that is how you can find your maximum capacity of a rapid transit system. You can also go in the opposite direction. Let's say you have conducted a survey and you know the number of persons who are traveling from one point to another point in an hour. So based on this, you can set around your number of seats, your number of coaches, how frequent you want your bus to be. You can manage all that. So basically, that was it for today's lecture, and hope you guys enjoyed it. So thank you.